Hello my friends and welcome back to the You Can Do TV channel. At the forefront of Mulvan stands as a model of digitalized, high-capacity sawmilling. Under the Modernization Initiative, this facility combines advanced automation, intelligent scanning, and optimized material flow to redefine production efficiency within the Mulvan network. Logs enter a precision tapering system that adjusts geometry before primary breakdown, maximizing fiber recovery. They are then graded and sorted to either the bandsaw line for large diameter timber or the small log line for optimized yield. An integrated X-ray frame with three-dimensional scanning technology performs internal defect detection and external shape analysis, generating real-time cutting solutions. During sawing, center cuts and sideboards are separated with millimeter accuracy. Automated board scanners evaluate surface quality, while structural grading systems classify center sections. Lumber is sorted by dimension and strength class before automated stacking. Drying operations combine conventional kiln chambers with a high-capacity TC dryer under construction, ensuring controlled moisture reduction and dimensional stability. The result is a streamlined, data-driven sawmill engineered for maximum recovery, consistent quality, and future-ready scalability. Construction of the B.V. Windishofer dairy facility began with precise site preparation and reinforced concrete foundations engineered to support high vertical and lateral loads. Glued laminated timber pendulum columns were erected first, forming the structural grid. Prefabricated beams were then craned into position, creating the main load-bearing framework for the freestall barn, calf housing, milk room, and hay storage hall. Large span saddle roof beams and monopitch rafters were installed sequentially, ensuring alignment and structural stability before roof diaphragm integration. Insulated roof panels were mounted to complete the weather envelope, followed by wall cladding and ventilation components. Interior partitions defining the milk room and calf areas were constructed after the primary shell achieved structural rigidity. Stall systems, feeding lanes, and service corridors were then installed within the freestall barn. Throughout the process, prefabrication minimized on-site adjustment, accelerating assembly while maintaining dimensional precision. The result was a structurally optimized agricultural complex delivered with efficiency, accuracy, and coordinated sequencing. Before it becomes a place to sit, a wooden chair begins as raw fiber, quiet, unshaped, full of potential. At Carlywood Products, that transformation unfolds through a precise choreography of engineering and craftsmanship. Production begins with thin wood veneers. Each sheet is moisture balanced and visually graded before passing through a controlled glue application line. Adhesive spread rates are carefully calibrated to ensure full surface bonding without excess saturation. The veneers are then cross-layered according to structural requirements and transferred into a high-pressure hot press. Under precisely regulated heat and compression cycles, the layers fuse into engineered plywood panels with enhanced strength, stability, and resistance to warping. After pressing and conditioning, panels enter the digital fabrication stage. Computer numerical control machines translate design files into complex geometries, cutting joints, curves, recesses, and structural cavities with repeatable precision. This stage ensures tight tolerances and efficient material utilization while preserving structural integrity. For turned components, solid wood blanks are mounted on precision lathes. Controlled rotational cutting refines symmetry, diameter, and surface quality. Meanwhile, router tables equipped with high-speed spindles shape edges, create profiles, and machine grooves. Feed rates and cutter selection are optimized to minimize fiber tear-out and maintain crisp, clean detailing. Assembly follows a structured sequence. Components are dry-fitted for dimensional verification before adhesive bonding and mechanical fastening secure the final form. Structural alignment, joint compression, and curing time are carefully monitored to ensure durability under load. Surface preparation is meticulous. Progressive sanding eliminates machining marks and prepares substrates for finishing. Protective coatings are applied in controlled environments to achieve consistent film thickness, clarity, and wear resistance. Selected models receive tailored leather upholstery, precisely cut and tensioned for a refined finish. Final inspection verifies dimensional accuracy, structural performance, and surface quality before protective packaging completes the process, delivering a chair engineered for longevity and precision. What defines true distinction in high-end classical furniture? The answer is not found in automation or speed, but in the uncompromising discipline of handcraft. At Vimercati, excellence begins where machinery ends, at the hands of master artisans whose precision, intuition, and experience shape every detail. Each piece is built entirely by hand in Italy, from the initial selection and cutting of solid wood to the final finishing touches before delivery. Traditional joinery methods replace mass production shortcuts. Carved ornamentation emerges slowly under skilled chisels. Surfaces are shaped, refined, and polished through patient, multi-stage sanding. Finishes are applied layer by layer, enhancing depth, tone, and durability. No two pieces are identical. Subtle variations in carving, grain, and hand-applied patina give every creation a singular identity. In the factory tour, the full process is revealed, an unbroken chain of craftsmanship that transforms raw timber into timeless furniture. This is not simply production, it is heritage preserved through mastery. For centuries, the raw power of water turned its massive wheel, driving a single-blade saw that shaped timber and sustained local life. Yet time took its toll once more. The old wooden wheel, battered by decades of spray and weather, began to rot and fail. Enter Patrick Husser, a talented young carpenter apprentice from Necker. He set out to rebuild a brand new 5-meter overshot water wheel. This wasn't just repair, it was a masterful fusion of ancient woodworking tradition and cutting-edge precision. The journey began with meticulous digital planning. Using advanced computer-aided design software, every curve, spoke, and bucket was modeled to perfection, ensuring flawless balance, strength, and efficiency. Then came the real-world measurements. The old wheel was carefully surveyed and documented down to the millimeter, preserving every detail for faithful recreation. High-quality, water-resistant larch was chosen for the side cheeks, buckets, and floorboards, while sturdy oak formed the spokes. The circular cheeks were built in segments, precisely cut, then glued and clamped under immense pressure until they formed two perfectly round, rock-solid rings. Each bucket slot was hand-chiseled deep into the wood, creating tight, enduring joints. Oak spokes were cut to exact lengths, buckets carefully shaped and smoothed to capture water like cupped hands, maximizing every drop's force. In the workshop, the magic of assembly unfolded. Spokes radiating from the central axle like the rays of the sun, cheeks locked in place, buckets fitted securely, and floorboards completing the watertight compartments. The entire structure was test-spun, adjusted, and perfected. Transporting this giant to its remote, steep riverside spot demanded ingenuity. The wheel was moved by truck, then lifted in two halves by crane over the sawmill roof, and carefully joined on the bank under clear spring skies in early May 2016. Finally, the moment of truth arrived. On September 10, 2016, Switzerland's Open Heritage Day, the water channel was opened. Within seconds, the new wheel caught the flow, spun smoothly, and powered the saw once again. A fresh log was fed in, and the blade sang through the wood in a triumphant first cut. Today, this beautifully restored sawmill stands as a living testament to Swiss craftsmanship, where centuries-old techniques meet modern ingenuity. Visitors can witness the wheel turning, hear the rhythmic creak of wood and water, and feel the pulse of history come alive. Long before wine ever touches oak, the story begins in the forest. For cuves et foudres enchaînées, oak casks and tanks, the material is everything. Carefully selected oak is seasoned, stabilized, and prepared for transformation. Each stave is trimmed with precision, its grain evaluated, its thickness calibrated. Then comes the bending. The staves are assembled upright into a circular form, temporarily held together as heat and moisture reshape the wood. A controlled fire is lit inside the forming cask. Temperature is carefully monitored, not guessed, because heat defines character. As the wood softens, it bends inward under tension, gradually taking its permanent curve. Steel hoops are driven into place, locking the structure together through compression alone. For larger oak tanks, the process expands in scale and engineering detail. Design specifications dictate diameter, height, and wall thickness. Staves are shaped and assembled into towering cylindrical forms. Openings are cut precisely according to technical drawings to accommodate access doors, drainage systems, and fittings. Metal hoops reinforce the body, while internal and external steel frames are installed through pre-cut apertures to guarantee structural stability. What emerges is not simply a container, but a calibrated aging environment, crafted through fire, force, geometry, and time. In the heart of Thailand, inside PL Wood Factory, raw timber begins a quiet transformation into refined kitchen and tableware. It starts with carefully selected hardwood, measured and cut with precision. Each piece is shaved to uniform thickness, preparing the surface for flawless bonding. Under controlled pressure, components are glued and seized, forming a solid, stable foundation. Planers refine the dimensions. Forming machines sculpt the silhouette. What was once a simple block of wood now begins to resemble a spoon, a bowl, a serving board. Sanding is meticulous. Outside sanders smooth every curve. Inside sanders reach deep into contours where hands will later rest. A protective coating is applied, enhancing durability while preserving the natural grain. Finally, each piece is inspected, checked for balance, finish, and strength before it leaves the factory, ready for kitchens around the world. Wood has carried culture across centuries. Holz als Kulturträger vergangener Zeiten and remains a renewable natural material with a decisive future. It grows within the most environmentally responsible production facility on Earth, the forest ecosystem. In the Black Forest, sustainably managed local woodlands supply the raw material that defines Bayer's pallet manufacturing philosophy. Regional partner sawmills process the timber close to its origin, ensuring short transport distances and reduced environmental impact. Rigorous quality control guarantees consistent material performance. High automation combined with maximum flexibility characterizes production, where modern robot-assisted lines manufacture standard Euro pallets, system pallets for high bay warehouses, and custom-engineered solutions tailored to specific logistics requirements. Compared to plastic, wood pallets offer cost efficiency, structural strength, and lower tear weight, enhancing storage capacity and operational economy. Since 1995, ISO-certified processes have ensured compliance with international standards. One of southern Germany's largest drying facilities optimizes wood moisture content, meeting hygiene and global export regulations. Sustainability extends beyond materials. Biomass cogeneration plants utilize residual wood for clean thermal energy, while a 700 square meters photovoltaic installation supplies renewable electricity, uniting economic performance with ecological responsibility. From raw timber to refined comfort, building a sofa by hand is a disciplined craft where structure and artistry meet. It begins with carefully selected hardwood, cut and assembled into a rigid frame, using reinforced joinery designed to withstand years of daily use. Every joint is aligned, clamped, and secured with precision to ensure long-term stability. Support systems follow. Webbing and springs are installed to distribute load evenly and create balanced resilience. Layer by layer, high-density foam and cushioning are shaped to achieve ergonomic support and consistent contours. Finally, upholstery transforms the structure into a finished piece. Fabric is measured, tailored, and stretched with controlled tension, seams aligned with exactness. Each staple, stitch, and fold contributes to durability and visual refinement. The result is more than furniture. It is a handcrafted system of comfort, engineered by skill, patience, and precision. In 2022, competitive pricing in wooden clothes hanger manufacturing depended not on shortcuts but on process optimization and disciplined quality control. Precision cutting lines convert raw timber into standardized blanks, followed by panel splitting to ensure uniform thickness. CNC milling refines the hanger profile, while tenoning machines create accurate joints for structural consistency. Notches for hooks and pants bars are cut with tight tolerances. Components are then glued and jointed under controlled pressure, forming a stable frame capable of supporting garments without deformation. Grinding is executed in multiple stages. Initial sanding removes machining marks. Intermediate grinding prepares the surface for coating. Final hand sanding eliminates micro defects prior to finishing. Each hanger is inspected and graded before entering the painting line. Automated spray booths apply smooth, even color layers. After drying, the finish is polished and checked for tone consistency. Metal hooks and pants bars are securely installed. What emerges is a competitively priced wooden hanger, uniform, durable, and ready for global retail distribution. Step inside the GCD Premium Cigar Box Factory, where craftsmanship defines every stage of production. The process begins with raw wood conditioning, stabilizing moisture content to prevent deformation over time. Panels are cut and assembled into rigid box frames using precise joinery to ensure structural accuracy. Each surface is carefully sanded to achieve uniform smoothness before entering the finishing phase. Multiple coats of stain and protective lacquer are applied under controlled conditions, enhancing grain depth while ensuring durability. Once cured, logos and decorative elements are silk screen printed with sharp alignment and consistent ink adhesion. Hinges are installed with calibrated positioning, lids are fitted for seamless closure, and every box undergoes final inspection to guarantee premium quality. At the Guitars factory, Guitar production is a tightly controlled engineering process built around acoustic precision and material stability. The workflow begins with systematic tone wood selection. Soundboards, typically spruce or cedar, are graded according to stiffness to weight ratio, grain uniformity, and moisture content. All wood is climate conditioned to maintain equilibrium humidity before machining. Computer numerical control systems cut body outlines, neck blanks, and internal bracing components with high dimensional accuracy. However, final thickness calibration of the soundboard is refined through controlled sanding to achieve target vibrational parameters. Braces are shaped and tuned to regulate resonance, sustain, and structural load distribution under string tension. After final surface preparation, the finishing phase begins. Ultra-thin, ultraviolet cured or lacquer coatings are applied in multiple controlled layers. Sides are thermally bent using controlled heat and pressure to achieve consistent curvature without fiber fracture. The top and back plates are bonded to the rim assembly using precision clamping systems to ensure airtight seams. Neck construction incorporates reinforcement systems to enhance long-term stability and resistance to warping. Fingerboards are slotted with exact scale positioning before fret installation and leveling. Surface finishing is performed using ultra-thin coatings, applied in controlled environments to preserve acoustic responsiveness while providing protective durability. Final assembly includes bridge positioning based on calculated intonation geometry, followed by nut and saddle shaping. Each instrument undergoes mechanical inspection, action adjustment, and tonal evaluation. The result is a structurally optimized acoustic system designed for consistency, playability, and controlled resonance performance. From a block of seasoned hardwood, a classic rocking horse slowly takes shape. The profile is traced, then rough cut to define the arched neck, sturdy body, and sweeping rockers. Skilled hands refine the form with chisels and gouges, carving the mane, shaping the muscles, and bringing life to the expression. Every surface is sanded to a satin finish, preserving crisp details while creating a gentle touch. In many homes, it serves not only as decor, but as a symbolic reminder of childhood, craftsmanship, and enduring holiday memories. Wooden bowl finishing is a discipline of precision and restraint. After turning, each bowl undergoes meticulous sanding, inside and out, to refine the surface, remove tool marks, and achieve a uniform tactile quality. Progressive grit sequences ensure the interior curves remain fluid, while the exterior profile retains crisp definition. Dust is fully extracted before final inspection to prevent contamination. Once the surface meets exacting standards, the maker's signature stamp is applied to the base. This mark signifies structural integrity, balanced form, and a finish ready for sealing, transforming a simple vessel into a certified handcrafted piece. In a bold demonstration of contemporary wood turning, Steve Paoli introduces an inventive method for crafting a monumental wooden vase defined by an intricate lattice structure. The process begins unconventionally. A massive timber blank is mounted securely on a heavy-duty lathe, then initially shaped using a chainsaw. This aggressive rough-forming stage removes bulk material efficiently, while establishing the primary silhouette. Once balanced, the piece transitions to precision refinement. Gouges engage the spinning surface, articulating curves and defining the complex open grid geometry. Structural integrity is carefully preserved as negative spaces are carved, transforming solid mass into a sculptural framework. Ready for sanding signals the next phase. Abrasives progressively refine the surface, eliminating tool marks while maintaining crisp intersections. A clear sealer is applied to stabilize fibers and highlight the grain. Speed drying at 100 RPM under controlled heat lamps accelerates moisture reduction without distortion. In a final architectural gesture, a concealed door is cut into the lattice body, followed by the installation of hinges and a latch. The result is not merely a vase, but a functional wooden sculpture merging engineering precision with artistic innovation. A complete wooden cable drum production line integrates timber processing, precision machining, automated assembly, and surface finishing into a continuous industrial workflow designed for high structural reliability. Production begins with the selection of seasoned softwood or hardwood lumber, graded for strength and dimensional stability. Boards are cut to length and processed into flange segments and barrel staves, using CNC saws and milling machines. The flange discs are assembled from multiple precisely machined segments, joined with dowels or steel reinforcements to ensure concentric alignment and load-bearing capacity. Barrel components are shaped and profiled to guarantee accurate fitment between flanges. Automated drilling units create bolt holes in drive pin positions with tight tolerances, critical for maintaining axial symmetry during high-speed cable winding operations. The assembly station integrates hydraulic presses and torque-controlled fastening systems to secure the drum core and flanges into a rigid structure. Steel bushings or reinforcement rings may be inserted to enhance durability under heavy cable loads. Following assembly, each drum undergoes sanding and edge chamfering to remove splinters and sharp corners. Protective treatments, such as anti-fungal coating or heat treatment compliant with ISPM 15 export standards, are applied when required. Final inspection verifies dimensional accuracy, structural integrity, and load rating. Marking systems stamp identification codes, production dates, and customer specifications before the drums are palletized for shipment. The result is a robust, transport-ready wooden cable drum engineered for safe storage, efficient winding, and long-term field performance. Every sheet of paper looks simple, thin, light, almost fragile. Yet behind that ordinary surface lies a process powered by thousands of tons of machinery, rivers of water, extreme heat, chemical reactions, and forests grown with mathematical precision. How does a solid tree trunk become something soft enough to tear by hand? How can recycled scraps covered in ink be reborn as perfectly clean white paper? In the southeastern United States, vast eucalyptus plantations are cultivated specifically for the paper industry. These fast-growing trees are harvested when the trunks reach a diameter of 10 to 12 inches, moisture content falls below 60%, and cellulose concentration reaches optimal levels. Modern harvesters, each capable of handling trees weighing close to 18 tons, perform multiple tasks within seconds. Hydraulic arms clamp the trunk securely, while computerized systems measure length and diameter in real time. Rotating rollers strip away branches and bark, feeding performance data directly into the control unit. The trunk is then cut into uniform logs, sized precisely for transport and pulp processing. GPS mapping ensures machines remain within designated harvesting corridors, preventing soil compaction and protecting surrounding young roots. The process requires minimal human touch, reducing risk while maximizing precision. Interestingly, much of the wood used for toilet paper comes from crooked trunks and young cores, unsuitable for lumber. Yet this material contains an ideal balance of short and medium cellulose fibers. On average, 1 ton of eucalyptus yields approximately 700 kilograms of usable pulp. A single plantation can produce thousands of tons annually without disturbing natural forests. Once felled, forwarders, specialized timber haulers, collect the logs. With powerful rotating grapples, they stack and transport massive loads across forest roads to centralized collection points. At the mill, the transformation intensifies. Towering piles of logs form walls of raw material across facilities spanning hundreds of hectares. The first mechanical stage involves industrial chippers, weighing several tons. Sharp rotating blades slice logs into uniform wood chips, measuring 2 to 3 centimeters. Precision here is essential. Oversized chips resist chemical penetration, while undersized chips risk fiber damage. This stage marks the first true test of controlled engineering. The chips enter digesters, where a mixture of alkaline chemicals and heat dissolves lignin, the natural adhesive binding cellulose fibers. From a 25-ton batch of wood chips, a milky pulp suspension emerges. Residual black liquor, rich in organic compounds, is captured and burned to generate energy for the mill, improving overall efficiency. Recycling further enhances sustainability. Using recovered paper can reduce energy consumption by up to 50% and save roughly 70% of water per finished sheet. Collected paper from printing houses, offices, and households enters automated sorting systems equipped with near-infrared sensors that identify material composition. Air jets remove unwanted particles. A single production line can process large volumes daily, creating a clean fiber base. Shredders with rotating steel blades reduce sorted paper into small uniform fragments. The pulp then undergoes 14 continuous treatment stages, including fine screening and centrifugal cleaning that removes sand, metal fragments, and residual wood particles. To eliminate ink, the pulp mixes with a specialized soapy solution. Tiny air bubbles attach to ink particles, forming a dark froth skimmed from the surface, leaving purified pulp ready for sheet formation. Inside paper machines over 120 meters long, diluted pulp flows onto moving mesh belts, water drains, forming an interwoven fiber network, the first fragile sheet. Press rollers exert extreme pressure to remove moisture, followed by heated drying cylinders that evaporate remaining water as paper speeds forward at over a mile per minute. Calendar rolls apply calibrated heat and pressure to ensure uniform thickness and smooth texture. Finally, the continuous sheet is wound, cut, embossed with micro patterns, packaged, and distributed globally, lightweight yet engineered through chemistry, thermodynamics, and mechanical precision. At the yard, specially ordered logs for PHS move into the debarking phase with methodical precision. Each log is unloaded individually and placed directly onto the chain conveyor system. From there, it advances into the debarker, where rotating cutting heads strip away bark without damaging the structural fiber beneath. This controlled process ensures clean surfaces, improved processing efficiency, and optimal material quality for the next production stage. After debarking, each log moves to the primary saw line. Equipped with powerful drive motors and precision-guided blade systems, these machines maintain stable feed rates and cutting accuracy under heavy load. The result is efficient breakdown, consistent board dimensions, and optimized material recovery in large-scale lumber production. Inside Santiam's sawmill, the cutting edge of modern lumber production comes to life. Unique interior footage reveals what it is like to be a log, traveling through a high-speed sawmill line. From the moment a log enters the debarker, it is scanned, measured, and optimized by computerized systems that determine the most efficient cutting pattern. Conveyors move the log rapidly toward powerful head rigs and bandsaws. Precision-guided blades slice through the drevesina with remarkable accuracy, transforming a rough trunk into dimensional boards within seconds. Automated sorters separate pieces by size and grade, directing them to stacking systems. The experience is intense, fast, mechanical, and precisely controlled, demonstrating how technology maximizes yield while maintaining industrial-scale efficiency. In Tainan, a landmark in mass timber engineering has redefined what is structurally possible with cross-laminated timber. This three-story building, crowned by three distinct towers and rising to 21 meters at its highest point, stands as the world's first CLT structure to deploy the revolutionary Rothablas X-Rad connector system. Engineered as Taiwan's third CLT project, the development required approximately 640 cubic meters of cross-laminated timber delivered through 20 40-foot containers. Every panel was precision fabricated, then assembled with the X-Rad system, an advanced concealed connector designed to optimize load transfer, structural stiffness, and seismic performance. The system's geometry allows multi-directional force distribution, making it particularly suitable for complex vertical configurations, such as the project's triple tower composition. To ensure durability in Taiwan's humid subtropical climate, X-Seal protective covers were integrated, providing enhanced weathering resistance and fire protection for the connector interfaces. The execution was led by President Stan Chiao of Woodtech Taiwan, with product management oversight and international consultation supporting the assembly strategy. More than a building, the project signals a pivotal shift in Taiwan's timber construction sector, demonstrating how advanced European connection technology can be integrated into high-performance Asian mass timber architecture at scale. At the Skilled Builders 2015 exhibition, the structure rose with the precision of a well-rehearsed performance. Glulam columns, 140 by 280 mm with integrated packing pieces and pre-installed connectors, were set first, establishing the structural rhythm. Secondary spruce beams, grade GL28 and cut to exact 240 by 600 mm dimensions, locked into place, each weighing roughly 500 kilograms, only a quarter the weight of comparable concrete members. 60 mm, 3-layer cross-laminated timber wall panels, factory cut to 4.8 meters, were lifted using removable hooks and secured with specialized connectors and pre-machined jointing strips. Breathable waterproofing membranes, battens, and the proprietary Parklex facade system defined the envelope. Schueco aluminum curtain wall glazing, 40 mm glass wool insulation, engineered acoustic flooring, and precision drywall installation completed a structure that demonstrated speed, strength, and modern timber innovation. Before a door ever stands between spaces, it begins as a promise of security, silence, and design integrity. At Lux Door, production is driven by the philosophy that a door is not merely a panel on hinges, but a structural element that defines comfort and character within a building. CNC machining centers execute accurate cutting of door leaves, hinge recesses, and lock pockets, ensuring repeatable tolerances across production batches. Edge profiling and panel detailing are performed with automated milling systems, allowing for both modern minimalist lines and classical decorative geometries. Surface preparation is critical. Multi-stage sanding lines create a uniform substrate before primer application. High-pressure spray booths apply eco-certified paints or veneers under dust-controlled conditions. Glass panels are first cut to match the exact geometry of each door model, whether rectangular, arched, or custom contoured. CNC-guided cutting tables ensure dimensional accuracy and clean edge quality, minimizing post-processing requirements. Following shaping, decorative patterns are applied using ceramic ink printing or sandblasting techniques, depending on the design specification. These motifs may range from subtle frosted textures to intricate ornamental graphics, permanently fused to the glass surface through thermal curing to ensure durability and scratch resistance. The result is a finished door system combining structural stability, aesthetic precision, and long-term operational reliability for residential and commercial interiors. The world's tallest wooden wind turbine tower represents a breakthrough in sustainable structural engineering. Constructed from engineered timber, often glulam or laminated veneer lumber, the tower combines renewable material benefits with high load-bearing capacity. Precision fabrication ensures straightness, uniform section properties, and tight connection tolerances between segments. Modular timber sections are joined on site using high-strength steel connectors and internal reinforcement systems designed to resist dynamic wind loads and cyclic fatigue. Timber's natural vibration damping enhances structural performance, while reduced carbon footprint supports climate-friendly energy infrastructure. This engineered solution demonstrates how mass timber can rival steel and concrete in tall, demanding applications, expanding the future of renewable energy construction. At the intersection of craftsmanship and contemporary luxury, Vismara design represents the refined excellence of made-in-Italy furniture production. Each piece is conceived not merely as functional decor, but as a statement of identity, where design, engineering precision, and artisanal mastery converge. Production takes place entirely in Italy, where skilled craftsmen shape premium materials, including fine woods, lacquers, metals, leathers, and bespoke finishes. From structural framing to surface detailing, every stage is executed with meticulous control. CNC machining ensures dimensional accuracy, while hand finishing techniques preserve the warmth and individuality that define true luxury craftsmanship. Signature collections often integrate advanced features, concealed storage systems, integrated lighting, multimedia compatibility, blending aesthetics with performance. Multi-layer polishing and high-gloss lacquering create depth and visual richness, while rigorous quality inspection guarantees flawless alignment and durability. The result is more than handmade furniture. It is tailored interior architecture, exclusive gaming tables, home cinema units, wardrobes, and cabinetry, engineered to elevate private spaces with Italian sophistication, precision, and enduring elegance. The Pezolato Professional One is a high-performance firewood processing system engineered for professional operations. Designed for inline log handling, it cuts large-diameter timber with a powerful carbide-tipped circular saw, delivering clean, accurate sections. Logs are automatically transferred to the splitting unit, where multi-way hydraulic wedges divide wood efficiently for uniform firewood output. The machine can be powered by an electric motor or tractor PTO, offering operational flexibility. Robust construction, integrated safety systems, and optional conveyors enhance productivity, making it a reliable solution for continuous, large-scale firewood production.